Greetings everyone and welcome back to the bench. Today on the bench I have the JAT EZ AMP project. It was sidelined because, well, it likes to blow up the outputs. I really don't know what the problem is. I could never figure it out. I could never capture the event on the scope. But I'm curious how this performs on the analyzer. I'd like to get it working again. But before we get into this, I want to update you on some projects. Well, like in the last video, I said the JAT 801 project is revived again and have some design changes and a bunch of tests to run and hopefully finalize that project. If you're not familiar with that, it's a higher power version of the JAT 501. So you can get up 150, 200 watts depending on the load impedance. Another project that's potentially revived here is the speaker project. I found somebody who is willing to take on building the speaker cabinets. I don't have all the tooling and expertise to build a really nice looking cabinet, and somebody offered to take care of that for me. So that's really great news, but I won't say much more on that until we get a little further into that project. So look for that coming up. In a video where I compared the LM3886 against the TDA 7293, so I had a board that I made and a couple of those kit boards from China, and I was kind of getting some interesting results with the power measurements between different load impedances. And somebody contacted me and offered me to send some TDA 7294 chips, which are pretty much the same performance as the 7293s. So I'm going to build one of those up on a board and test it out and see how it performs. Also have one of these music players here. It's not an amplifier, it's just a music player. And somebody sent this to me asking if I would test it on the audio analyzer to see how it performs. So yeah, we'll do that in an upcoming video. And finally, I have some parts to upgrade my computer, and I might make some extra content type footage for that little project, see how that goes. So for now, let's take a look at the EZ AMP and see if we can get it running again. Okay, so the JAT EZ AMP. If you haven't followed this thing at all, it's actually been a couple of years ago at least, well, probably longer than that, but so I have the JAT 501 project that's been completed. Turned out to be a very nice amp. It works really well, but I wanted something, below that, something a lot simpler. Might be easy to perf board if you didn't want to, have boards made or something like that. So I come up with a really simple amp. I use Darlington type outputs. I cut down on the input stage. There's no current mirrors. So yeah, and you can see it's a pretty basic amplifier circuit here. There's not a whole lot to it. So I assembled it on the perf board, and initially everything was working okay. Thermal stability's good. It would play music, it'd sound okay. But when I started doing power tests, the transistors would blow, the outputs would blow, they would just short out. I tried to capture the event on the oscilloscope, I didn't see anything. I started doubting these transistors. They're Darlington transistors. Let me see what I have in there now. BDX34BG and the complement 33BG. So I dug this thing out. It's been in the parts box for several years, and I dug it out, and of course I've changed the transistors, and it's working. So I hook it up and play some music. It's working just fine. Let it run for a while. Thermal stability is perfect. It sounds good. I'm letting it play through a song. I go off and do something, and suddenly the music stops. I come back and the output's shorted. I was playing it at lower voltages. Supply voltages is only at plus minus 12 volts. The music wasn't loud. the heatsink was cool, it just stopped. And I measured the output, and and I had a supply rail on the output. Luckily, I was only running it at low voltage and it didn't hurt the speaker. It just, again, it just shorted. You know, it was non-stress conditions. I was probably operating at just a few milliwatts of output. Why does this thing blow up? I just don't get it. Is there a bad solder joint or something here? I don't even see how that would short out the transistor. I mean, my power supply is limited in current. But anyway, let's hook this up and take a quick measurement here. Okay, got it hooked up here. I'm just running it at plus minus 12 volts again. And this is what's on the output. A negative 11.35 volts. So it's not a dead short, because it would be 12 volts. So it still could be the transistor's bad, but you know, it's not a hard short. Matter of fact, if I short this resistor across the output, it's a 10 ohm. See, it drops to about 9.9 volts. So yeah, it's not a hard shorted output. So it could be that transistor is being driven to the negative rail. Something else has opened maybe. It's not acting as a pure voltage source because it, you know, it loads down, as you can see. So yeah, let me dig up the schematic here and work my way around the circuit, see what's going on. Okay, I found the schematic on the computer of the JAT EZ AMP. Bootstrap and discrete output. I guess I gave up on the Darlingtons because I'm using a separate driver and output transistor here. But that's okay, we can still use this. So what would pull this output negative? Well, obviously if the output and the driver shorted, it would let the electrons flow from the negative rail to the output. And let's see, if this transistor shorted, same thing, it would allow rail voltage to the base of the output driver, and that would pull it, it would turn it on and pull it negative. And let's see, if something opened in this stage of the amplifier, now if there was a break in the circuit here, that would let this transistor pull this side down negative, so that could be an issue. Input stage really doesn't see any sort of current. It's got a constant current source, and it's really a very small amount of current flowing there. But let's see, if this transistor conducted more, it would pull this line up. That's the base to this transistor. That would turn this on more. And if this was open, this would be pulled down to the negative rail, which would turn this transistor off, and the output would go more positive, and that's not what we're seeing. So yeah, that's the things I should look for. Start checking these transistors. Of course, the one on the board's Darlington here, and the rest of the circuits should be about the same. I don't remember changing much there. Of course, this circuit is a prototype. It's not been fully tested and all that good stuff. I'm not really finding any shorted transistors. Everything seems to be at least a diode drop. That doesn't mean the transistor can't be partially degraded, but it is kind of hard to test in circuit, especially Darlington type transistors, because they'll have base to emitter diodes that help remove charge carriers to speed up their action, and plus you got in circuit, and some of these Darlingtons have an emitter to collector reverse diodes. And another example here, I'm trying to test this base to emitter junction, but if you look back here, you see there's a loop. There's a resistor in parallel with that junction. So it's going to thwart measurement attempts. So looks like I'm going to have to pull devices out. I don't know where to start. I'm kind of pointing towards the output. You know, this Darlington here, this lower output, I have the board upside down. And this voltage amplification stage transistor, that's really the main two things that could go bad. You know, there's no burned up resistors or anything. Of course, being a perf board, there could be a bad solder joint. But it was never flaky, it just popped open one day and was putting voltage on the output, that negative rail on the output. Okay, I pulled out the bottom Darlington output, voltage amplification stage transistor, and yeah, it's reading. These are the ones with the internal diode. Gain's not very high. It might be due to those base emitter resistors which shun away some current. I don't know, I'll have to check that further. Let me check the amplifying stage transistor. See if I can get that in there. Can't see what I'm doing. Okay. And that is perfectly normal. So, those parts seem okay. Okay, got the parts back in. You can see how I ran traces with copper wire. Kind of hard to solder these back in. You have to make sure they're not shorted. And this is the compensation capacitor. I'm not sure that was connected before. I could have moved it when I was desoldering it, because there should be a line from capacitor to the base, capacitor to collector, and it goes over here. There's just a piece of wire. So when I was first building this thing and clipping wires off, I might have cut that, but I would think the thing would oscillate. But if it wasn't connected, that could be a reason why it popped. Though, like I say, I didn't see any oscillation. I'll have to investigate that. And this wire, I don't know, I thought it was loose. But again, it could have been when I was desoldering it. Well, I'll hook it up and see. Okay, I hooked it back up. No excessive current draw. No more rail on the output. So there was a loose wire. A wire must have just popped off. 74 millivolts of offset though, but that's just the way it is with this type of amplifier. I'd have to put a control to fine-tune that. So what happens if I unplug the Miller compensation? It's not drawing heavy current. So maybe that Miller compensation was disconnected. But that has nothing to do with the rail on the output though. That could be why I was popping those transistors before, because maybe there was a spurious oscillation and it popped those. It's just a screw up in the wiring on the perf board, which can be quite easy to do because it is kind of hard to see. What I'm going to do now is demonstrate what an underbiased amplifier sounds like with crossover distortion. And I notice that you can really hear it with certain types of piano music. And hopefully this doesn't hit the copyright detection. Alright, play. I don't know if that comes through, but you can hear like a fuzziness. Now I'm turning the control. Gone. Completely cleans it up. So that's why it's important to set the bias on your amplifier. You can do it by ear, but normally you want to set it optimally using the voltage drop across the emitter resistors in the output stage. But anyhow, I'm going to put this thing on a heat sink and do some tests. Okay, I've been playing some music for a while, cranking it up, and some heat into the thing. Bias is rock steady. After warming up, it's still at 70 milliamps. That's the total draw of the entire circuit. So yeah, it's staying steady. So what I'm going to do a few more tests, and I'll put the audio analyzer test in another video, or this video is going to get real long. So yeah, I just want to make sure the circuit is working okay before we proceed. I'm testing the stability of the amp with the square wave test. I have a capacitor across the output, the 0.1, using my standard test. The compensation cap has been lowered to 47 picofarad. The coil I had in the circuit is inadequate for that. It does oscillate. So I put the proper coil in. Usually my standard 0.7 to 1 microhenry coil tends to make any decent amp oscillate, oscillate. Stable, that's what I'm trying to say. And I can sweep the level, and it never breaks out into any sort of oscillation. That's a nice damped ring there. Let's go to 4 ohm, which usually dampens it more. Yeah, staying stable. And the amp has not shorted out or anything like it did before. After those strenuous square wave tests, look at the bias, still perfect. Yep, so the amplifier is working perfectly. It's thermally stable, electrically stable, and well, it's not blowing up its outputs anymore during these tests. So I'm going to stop here, and in an upcoming video I'm going to run it through the ringer of the Quantasylum and see what kind of distortion performance it has. It should not be as good as the 501 because it doesn't have all the parts in place that help reduce the distortion, but I'm expecting very reasonable performance from it, and we will see that soon enough. And I thank you for watching.